Alright, hello everyone, welcome to our Game Dev Club's Spring 2019 tutorial. Today we'll be making a top-down shooter, and let's go ahead and get started right away. So I'm going to open up Unity Hub. If you were just using an older version of Unity, you may see something different, but here I'm just going to go ahead and create a new project. And you can name this whatever you like, say like top-down shooter. 27, you choose whichever version you want, save it wherever you want. Make sure that the template is 3D. This is because we're going to be making this game in 3D instead of 2D today. Now I've already made this project, so we don't have to sit through me creating all the packages and stuff that we need. So feel free to pause the video here as your Unity does so. But when you open up Unity, this should be the scene, or something similar to this, that you see. Now, let's go ahead and dive into what all these windows are. So by default, this is in the scene view. You can see up here, this is the view of, there's like a grid on the bottom here, a skybox, that's the sky, you can see the sun over there. This is just a place for you to place all the objects that are going to be in your game. And what you can see over here in the hierarchy window on the left, a list of all of the objects in this sample scene. So Unity's gone ahead, at least in the new version here, 2018.2, has gone ahead and created a scene for you, sample scene. If not, you may need to save your scene, and then you can put it in any folder you want, but I'd recommend, yeah, just, you can save it wherever you want, but inside the assets folder. This hierarchy lists every object that is in the scene. So this main camera, this is what's used to render this is what the player sees, basically. This chooses what the player sees, and then the directional light casts light all over the scene. You can see if we disable this object over here, the scene gets noticeably dimmer, but we want light in our game. I'm going to leave that on. So you'll notice here on the right side that there's the inspector tab. Now this is a very useful tab. When you click on an object or something else in your project, provides a bunch of different information about that object. So a bunch of different, like for example, on these objects in the scene, you click on those, you get to see a list of all of the components that are on that object. For example, the directional light has a light component, whereas the main camera has a camera component. Now, any object in your scene, so any object that shows up in the hierarchy, will have this transform component, and this transform component tracks the position, rotation, and scale of that object. Now, if you're curious as to what your player will see, you can go ahead over to this game tab here, little Pac-Man icon next to it. It'll show you exactly what the camera sees, which at the moment isn't very much, but make sure that, again, up here, it might say free aspect. So that means it'll scale to the size of your window rather than the forced resolution of 16:9, which is what most monitors have nowadays. But you can also create a different resolution if you have a specific resolution in mind for your game. But anyways, that's pretty much it for what we need to cover in terms of how Unity is laid out. So let's go ahead and make a player object. Now, this is 3D, and typically you'd use a 3D model here, but since we're just doing a beginner tutorial, I'm just going to use a placeholder capsule. So I'm going to right click here in the hierarchy. I'm going to create a 3D object, and this is going to be a capsule. You'll see that creates it way over there, and the reason for that, you'll notice in the transform, its position is way off center. Let's go ahead and click on this little gear icon here on the top right of the transform component, and just reset that to bring that back to 0, 0. You'll notice now in the game window, little capsule has appeared in the center of our screen. So clicking on the capsule here, you'll notice all the different components it has. The mesh filter and mesh renderer components simply handle drawing the object to the window so it can actually be seen, and the capsule collider gives it this faint green outline here that basically tells Unity's physics engine that this is a collision box, and then any other collider that collides with this collider should result in a collision. Okay, so we have a player of sorts here as a placeholder. In fact, I'm going to rename the capsule to player, just to make sure that we know exactly what this capsule is. Now, since this is going to be a top-down shooter, and we're going to be looking at this from above, by the way, you can use the right mouse button to pan in the scene, and the middle mouse button to move yourself around. You can also use the arrow keys to an extent to move around and navigate the scene. But we will be in a top-down perspective, and you'll notice it's very hard to tell with symmetrical objects such as this capsule when they are rotating. So, clicking on the player, we're going to find the forward direction that the player is facing, and that is represented by this blue arrow here. This blue arrow is the z-axis, so you'll see if we move it along this axis, that will move it on the z-axis. Now if you don't have this, go ahead and make sure on the tool shelf here in the top left that you're in the transform tool, and then find the blue arrow here. You can also press W as a shortcut to get to this tool. We'll cover these tools in a moment here, but for first, let's go ahead and give our player a gun that he will need for a top-down shooter. So again, we don't have a 3D model for a gun, so we're just going to create some sort of placeholder. Now, this sort of way of creating placeholders to like represent stuff is really useful in game dev, because you can use it to really quickly prototype out game ideas that you may have without committing to making assets or like trying to get something you know, that looks good to make sure that the idea will actually work. So let's go ahead and right click on the player object and then create a 3D object, and this time we're going to create a cube. So you'll see that'll spawn a cube in the center of our player, and you'll also notice that in the hierarchy it's in a drop down underneath the player. This means that the cube is a child of the capsule, and if we move the player around, the cube moves with it, which is really useful for us because we want the gun to move with our player. Now if you have the cube out here, for example, and it's not a child, to make it a child of the player, all you need to do is drag it onto the player, and that'll parent it to the player. Okay, so now both of these objects are really white, so let's give the gun a material, or a color, to differentiate it from the capsule. So in our assets panel down here, I'm going to right click, create, and I'm going to create a folder first, just to stay organized with this. You don't have to for this tutorial, considering how small of a scale of a project this is, but as games grow, they tend to grow cluttered very quickly, so it never hurts to stay organized as you work. So in our materials, we're going to go ahead and create a material, and this is going to be the gun material. So you'll notice with the gun material selected, the inspector has a bunch of different information about stuff you can change in here. You can give it a normal map, do all of this stuff, but for us, all we're really concerned about is the color of the material. We're just going to go and click on this little color thing, and that'll bring up this color menu here, and we can just go ahead and slide this down to black, or you know, whatever color you want your gun to be, and then take this gun material and just click and drag it onto the cube. Now you could also go onto the cube here, find its mesh renderer component, scroll down to the materials dropdown, and then slot it in here under element 0, but clicking and dragging works great as well. In fact, while we're here, I'm going to rename the cube to gun as well, so we remember what the cube is. And now we're going to cover the other tools I mentioned earlier. So up here in the tool shelf, you'll notice we have 6 tools. We have the hand tool, it allows us to use the left mouse button to pan around. We have the rotate tool, which lets us rotate objects. We have the scale tool, which lets us scale objects. In fact, that's what we'll be using in a moment. We have the bounding box tool, and we have the everything tool, which just combines the rotation, translation, and scale tool. So the keyboard shortcuts for these are QWERTY, so QWERTY, respectively, to each of these 6 tools. So R, which is the 4th tool and the 4th key, will get us to the scale tool. And we're just going to go ahead and scale this down a little bit, maybe a little bit more. Scale it in a little bit so it gets vaguely square shaped. We'll see here how exactly that's looking. Let's do that down, scale it down a little bit more, and then move it out. Good. Okay, and then I'm going to move it forward a little bit, and that'll be the gun for the player. That's a pretty good placeholder, if I do say so myself. And you'll see from above, it very clearly tells us the blue arrow is forward, the gun is facing forward. This is the forward direction of our player, so when they rotate, we'll have a better idea of where exactly the player is facing. Now, while we're here, just for some added fun, if you will, I'm going to go ahead and duplicate the gun. And this will be the sunglasses for our player. Just a really quick tool to help the monotony of this part of the game. I'm going to rotate it by 90 degrees on the y-axis. I am going to make sure that it is on 0 on the x. And then I'm going to slide it in a little bit, up a little bit, scale it down that way, and keep sliding it back until we get this effect. And that, my friends, is one cool looking player. He is going to be killing lots of dudes today in this top-down shooter. But yeah, there we go. We have a player object. Now, we go ahead and hit play. Nothing really happens. He's facing away from the camera so we can't see him in all of his glory, but of course nothing happens. So we need to give some sort of way to control this player. Now the first step to this is to tell Unity that, its physics engine needs to sort of work with this object here. What we're going to do, we're going to go onto the player here. In the inspector here, we're going to add a component, and we're going to search for rigid body. Now, what the rigid body component is the component in Unity that handles most of the physics for any object, any given object in a scene. So you'll see there's a bunch of different physics-related properties here that we can change, whether or not we use gravity, and all of that fun stuff. But for this tutorial, we're going to ignore all of that and just freeze the rotation under this constraints dropdown, and freeze it on all of the axes, just so that when a player gets hit by the bullet, they don't go spinning off into the sunset. Cool. Now, if we hit play, bang, our player falls away because he is affected by gravity. So we do want some sort of ground for our player to stand on. He's looking very lonely out in this world. Let's go ahead and let's create a 3D object. Let's create a plane this time. I'll create a flat plane object that we can let our player stand on. Now again, it's not zeroed out, so on the transform component of the plane, I'm going to click on the gear icon and reset. So that'll bring the plane halfway into our player. We don't want that either. So we're going to shift this down on Y by like -1. That should be right below the player. That's perfect. And while we're here, I'm also going to scale the plane out so it is large enough for us to walk around on. Now it is glaringly white, so I am going to give it another material. This is purely for aesthetic purposes. You could go ahead here and create another material, but for me, I'm going to just use one of Unity's built-in materials in 2018, and use the spatial map wireframe material. Now, from afar, this looks like a normal gridded texture, but as you get closer, shit gets really cool. It's called colorful and shit. So that's why I really like this, just like debug stuff. But anyways, let's go ahead and get our player moving. So let's go out into our assets folder, create a folder, and this one is going to be scripts. And let's go ahead and create a C# script. Coding in Unity is in C#, but if you've taken Java, you're pretty well equipped to learn C#. They're pretty similar. Okay, we're going to name this player. Ideally, you'd name your scripts better. Indicate better what purposes they serve. But for our tutorial, we're just throwing all of the functionality into one script for the player, instead of splitting up movement and shooting like we should. That's just to speed up the tutorial, really. Nothing else. Okay, so when you create a script in Unity, you will be greeted with this sort of pre-generated code. It's using these 3 namespaces, which if you've taken Java is basically import of a bunch of libraries. The important one is, of course, the Unity engine namespace. This is the inherits of C# as to Java, or sorry, extends, I should say. But basically that player inherits from mono behavior. Now this mono behavior inheritance must be on any script that you want to put on an object in a scene. You can have normal classes to do like object-oriented programming if you'd like, but if you want the script to sit on an object in a scene, it must inherit from mono behavior. Okay, so there's a couple things we need to get our player moving. The first of which being some way to control how fast our player moves. And to do that, we're going to create a public float, and let's call this move speed. And I'm going to set it to default to 8. Now a float is just a double with half the memory space, but and that's what this f does, is it converts an integer to a float. You don't need this here. There is an implicit conversion, but It's really helpful to just remember to put onto decimals and stuff. So yeah, we have this. So now if we go back into Unity, click on our player, and add the player script, you'll notice that we have a script here with a move speed variable that is public to us. So we can actually adjust this here in the inspector. Now, what this also means is that if you adjust the value here, say I changed it to 7, and went back to Unity, it doesn't actually change here. Now the reason Unity does this is so that you can edit any public variables that you have here through Unity in the inspector and see the changes happen really quickly here, as opposed to going back to your code, changing a value arbitrarily, saving it, waiting for the code to compile here, and then testing it again. Instead, you can do it all in Unity, so you don't have to flip-flop back and forth, and it really streamlines the process of playtesting. Okay, so we have a move speed. Now, the other thing we will need to get our player moving is a reference to the physics of the player, because we're going to be moving our player with physics today. So I'm going to grab a private rigid body. Notice that this rigid body is the same as the rigid body component we added to our player moments ago. And I'm just going to call this rigid, but you can call it whatever you like. Now, this isn't assigned anywhere yet. This is just an empty reference, so we need to actually assign it. Now, start is called at the very beginning of the script's initialization. So in this case, when we press play, this start method is fired once and only once, and it's fired before the update method. Now the update method runs continuously. It is called once per frame. So once every frame, the update method will run. So that's really useful for like continuous tasks like movement or shooting. But anyways, we need to get a reference to the component rigid body on our player, because that's the one we want to interact with to tell Unity how to affect the physics of our player. So we're going to do get component. Now this is a method from the mono behavior that takes in a type t, and this type t that we're going to provide is of course the rigid body type. And that'll go ahead onto our object, so onto the object that the player script is sitting on, which in this case is our player, and find the component of type rigid body, and that'll, set all those references straight. Cool. So now movement is relatively simple in Unity, at least simple movement. So vector3 input. Now a vector3 is just a struct that stores 3 values in x, y, and z. In this case, they're just float values, so just numbers. Is equal to, and we're going to create a new vector3 object. And for this, we're going to be using the built-in Unity input system, so that'll track player input and stuff for us. So input.getAxis, horizontal. And then, since we don't want to move up or down in the world, we don't want to move vertically, I'm going to feed 0 for the y component. And then finally, input.getAxis, vertical. Hopefully my keyboard clacking isn't too loud, but okay. So the reason I'm using getAxis instead of the getAxis raw is that getAxis by default applies smoothing to the movement, so it's less jerky. But you could use getAxis raw to have snappy movement or to apply smoothing yourself. Okay, so we have the player input. By default, horizontal is the A and D or left and right arrow keys on your keyboard, or the left and right on the left joystick of your controller. Similarly, vertical is just the up and down movement. Okay, now to actually move our player, we're going to be using rigid, so the rigid body component reference we grabbed earlier, dot move position, and we're going to feed it in the position that we want to move to, which in this case is transform.position plus the input dot normalized. Now the reason we normalize this input vector is so that diagonal movement isn't faster than just normal side to side and up and down movement, or forward and backward movement rather in 3D. Okay, and then we also want to multiply this by our move speed so that we can control how fast we go. Because by default getAxis returns a value between -1 and 1, so it's it's going to be pretty constant, and move speed allows us a little bit more versatility in terms of moving the actual moving the player. Okay. And now we also want to multiply by time.delta time here. The reason for this is that, remember, update is called once per frame. So if we're moving 7 units every frame, that's hella fast. So we're going to be zooming around really quickly, And rather than reducing this value to some really small arbitrary decimal value, we can leave this as 7 as a more intuitive way to understand how fast we're moving, 7 units per second. Yeah, 7 units per second, and instead multiply by time.delta time, which is simply a scaling value. It's the time between each frame call. Yeah, the time it takes between each frame call, which keeps it consistent between variable frame rates, and also allows us to keep this intuitive understanding of how fast we're moving. Okay, if you've got that all down, go ahead and save the script. Go back into Unity, wait for this little circle in the bottom right to finish spinning. Once the code has compiled, you can go ahead and hit play. And now, we can move our player. The WASD, the arrow keys, or if you have a controller plugged in, you can test it out. The left joystick should move this as well. Cool. Now, one thing to note, the camera's behind us, we can't really see much. So while we're here, I'm just going to go ahead and move the camera so it's to a more top-down perspective. The first step I'm going to take is I'm going to reset its transform so it appears smack dab in the center of our player. I'm going to move it up on the Y by like 10 just to shift it up directly above the player, and then rotate it to look down. Now you could do this by doing that, or just looking straight down. We'll cover the camera more later. This should work for our purposes right now. Yeah, we can move around, and everything's cool. We can sort of see how cool our player is with his sunglasses and all. But yeah, that's looking great. Okay, the next thing on our plate is getting the player to look at the mouse, because ultimately this is going to be a mouse game. If you guys want, I can make another video later, sort of adding on to this to show how to look in the direction that the controller is playing if you want controller shooting. But the way this game is going to work is the player is going to look at the mouse. And if you click on the left mouse button, he's going to fire in that direction, and he's just going to follow the mouse around to look at. Okay, so the way we are going to do that. So first thing we need a reference to the camera. So we're going to create a private camera cam reference. In start, I'm going to go ahead and assign that to camera.main. Now, main is a static variable in the camera class, and all that does is it look for a camera in your scene that is tagged main camera. So if you go back to our main camera, you'll notice that it is tagged main camera. If it isn't, it's a good time to change the tag to main camera. Otherwise, this code will not work. But yeah, make sure your main camera is tagged main camera. And so what this will do, it'll grab a reference to that camera. Now, the reason we want to do this with a variable instead of just default calling camera.main down here is that camera.main does a similar thing to find object of type, which is a somewhat expensive function call. So it can slow down your game if you have large amounts of camera.main calls in update, since update's called once per frame. Okay, so the way we're going to get this sort of rotation to work, since the mouse doesn't actually exist in the 3D world with our player, it only exists on the screen in screen coordinates, we're going to bring our player into the screen coordinate world, and then do some quick vector math to find a direction to look from the player to the mouse cursor, and then sort of put that back into the 3D world. So to do that, we're going to create a vector 3. We're going to call this the player position to represent the player position in screen coordinates, and we're going to do cam.world, if I can spell here, to screen point. This will take a world point and translate it to a screen point. We're just going to feed it our transform.position. Remember, the transform component is on every object that inherits from mono behavior, so we can have this safely and assume that there is a transform component on this, so we don't have to go and get a reference to it. Instead, we can just use the transform that is provided to us. Cool. The next thing we need to do is calculate the direction in which to look. So I'm going to call this look direction. And this is simply going to be input.mouse position, which is a vector in screen coordinates, minus our player position. So if you've taken vector mathematics, this should make sense. If not, I apologize, but game development does use a lot of vector math. But all this is really doing is finding the player position and the mouse position, and then using the X and Y components of those vectors, basically finding another vector that points from the player to the mouse. Okay, the last thing we need to do is change our rotation. So on the rotation fields of our transform, we're going to set that equal to quaternion.look rotation, and we're gonna feed it in a new vector 3. So look rotation takes in the delta, or the rotation difference that you want to change. Quaternions are really confusing. Like, I'm not going to try and explain them despite knowing how they work. You really don't need to know how they work, because most of the time you're just going to convert to Euler angles, which is the traditional rotation in X, rotation in Y, and rotation in Z. But for now, that's ultimately what we're doing by converting to a vector 3 here. But yeah, I'm not going to talk about them for now. But what we're going to do, we're going to feed it the look direction.x. So look in this direction on the X, 0 on the Y, because we don't want our player to lean back or lean forward to look up and down. Remember, this is in 3D, so Y is up and down, X is left and right, and Z is forward and backwards into the screen. And then we want look direction.y. The reason we're using Y here instead of Z is because, remember, look direction is in screen coordinates, so on a screen it's a 2D coordinate system, so you have X and Y. There is no real, well, there is Z, but like it's not the Z that we want. So instead, this is the Z direction that we want, since it's a top-down shooter. Okay, so now we go back into Unity, wait for the code to compile, hit play. Beautiful, our player rotates to look at the mouse. And now we can get shooting. This is really cool. Alright, so let's go ahead and get shooting. But to shoot, we need a bullet. So, in our hierarchy over here, I'm going to go ahead and create a 3D object, and I'm going to create a sphere to represent our bullet. Again, I'm going to go to the transform and reset that so it appears back here. Shift it up a little bit just so we can see what we're working with. And let's go ahead and adjust some things about this sphere to make it look more like a bullet, as I rename it here. Okay, so first off, we don't want bullets to be this big. This is as big as our player. So I'm going to shift this down to like 0.4, 0.4, 0.4. More bullet shaped, or rather, the size is more close to a bullet, roughly. Okay, the next thing we want is to give this some sort of color, because bullets are dangerous, so we want to give this some sort of dangerous color, right? So I'm going to go ahead into our materials folder, and then create another material, call this bullet, and let's make this some sort of dangerous red. Red is dangerous, let's go with red. I'm also going to make it emission, check the emission property here, make it emit some small amount of light. It's just to make the material look a little bit brighter and pop a little bit more on the screen. Once again, I'm going to take the bullet, drag it on to the sphere that we've created, and there we go, that's a bullet. Now, the next thing we're going to do, we're going to go into our assets folder, and we're going to create a folder, and this is going to be a prefabs folder. Now, prefabs are super, super helpful, because say we had a bunch of duplicates of this bullet flying around, and, or like, this is a bad example because bullets ultimately are generated during the game, not before. But say you had a bunch of trees sitting around, let the bullets represent trees, and you realize, wait, I want to change one of these, like, the trees are all copies of another tree, right? But say, oh wait, I want this to actually be 0.3, like you want to change the size of one of the trees, and then you'd have to go through manually and change all of these to be a different size as well. But with prefabs, if you take this object and you drag it into a folder down here, that makes it a prefab. So what prefabs are really cool for is exactly situations like that. So say we had a bunch of duplicate bullets in the scene, and let's just move those away again. Like say I actually want this to be like that, right? You wouldn't have to go through and manually adjust any of these. Instead, you could go onto here, and at this new prefab menu at the top of the inspector, you could hit apply. and that would change every other object of that prefab in the scene to those settings. And that's really cool. Like, that's going to be really helpful for like making mass changes to stuff. So always make stuff prefabs if you're going to have copies of it sitting around the scene, or if you're going to be moving it in between scenes and you want it to remain the same. So I actually don't want it to look like that though. So I am going to revert this to the prefab. Cool. Okay, and get rid of these bullets. We can actually get rid of this as well because we're not done with this. Next thing the bullet needs is physics. So we're gonna give it a rigid body. What this will do for us is basically allow the bullet to have physics. The only thing is we don't want the bullets to have gravity or they'll drop really quickly. So I'm gonna uncheck use gravity, but the rest of the stuff I'm gonna leave alone. Now if you're doing this on this bullet, remember to hit apply here, otherwise it won't sync up with this prefab down here. So if you were doing it down here, you wouldn't need to hit apply because you're working directly with the prefab. But just make sure that the prefab at the end has this rigid body. Okay. And the next thing we need is some way to tell Unity where to start spawning the bullets. Because we don't want the bullets to just spawn in our player and then shoot out, right? We want them to spawn somewhere in relative proximity to the gun. What we're going to do, we're going to select the gun here. We're going to right click on it. We're going to hit create empty. So this will create an empty game object underneath it. So rather than like a 3D object like a cube or sphere with a bunch of components on it, this is just an object with only a transform and nothing else on it. Now this is really useful for like holding places, just like this one's gonna, as a placeholder I should say, which is exactly what this is gonna do. This is gonna be the spawn position. I don't know, you don't need to type it like that, but this is gonna be the spawn position of the bullets. Now I'm also gonna drag this out to somewhere around here, so it's a little bit out in front of our player. And this is gonna be where the bullets spawn, and it's in front of our gun barrel, so it'll give us the illusion of shooting from our gun barrel, which is really cool. Okay, so now to get shooting working, we need to head back into our player script. We're going to need a bunch of variables up here, so I'm going to go ahead and list these out. We're going to need a public float for the bullet speed, so how fast our bullets travel. I'm going to set this to default to 15 by default. We also need a public float for the fire rate, so how quickly we can fire. I'm going to set this to 0.1 by default. We also need a private float for the last time we fired, and I'm not going to initialize that one. And then we also need a few more public things actually, so just to keep this a little bit more organized, I'm going to create the public variables here. Public transform. This is going to be where we slot in the spawn position that we just made. This will tell our bullets exactly where to spawn. And we also need a public game object, bullet prefab. This is what exactly we're going to be spawning. What we're spawning is the bullet prefab. Cool, I think that's everything we need. If we need more, I will come back and add them, because I'm a very forgetful person. Okay, so let's go ahead down into our update function and start working on shooting. So for shooting, we want to check for some sort of input that we want to shoot. So I'm going to be using the default Unity Fire 1 button, which is the left mouse. So if input.get button down, you'll notice that there was also get button and get button up. The difference between those and get button down is that get button down returns true only on the frame where the button was pressed down. Get button returns true on all of the frames where the button is being held down, and get button up returns true only on the frame where the button is released. But we want down just because that's more intuitive, players. And if we do decide to fire, we want to shoot. Now shoot isn't a method we've created yet, so let's go ahead and do that. Returns void, and its name is shoot. And so the first thing we need to do is check, are we allowed to shoot right now? Has it been long enough since the last bullet was fired that we can shoot? So if last time fired, if the time minus the last time fired is less than the fire rate, then no, it has not been long enough, so let's just return and not do anything else in this function. Otherwise, let's go ahead and create a bullet. Let's create a GameObject bullet with the instantiate method. And this takes in an object to instantiate, which of course is our bullet prefab. It also takes in the spawn position, so our spawn position.position. It also takes in a rotation with which to spawn. We don't care, so we're just going to give it the identity rotation, or basically no rotation. And that should cover that. The next thing we need to do is give the bullet speed, because otherwise it's just going to spawn and sit there. So we're going to go bullet.getComponent. We're going to find the rigid body component on the bullet, so we can affect its physics. And we're going to directly set its velocity to be the forward direction, the direction that the player is facing, so the forward direction of the player, times the bullet speed. And that covers that. Now there are two other things we need to do. We need to make sure that we set the last time fired equal to this time, so that we know when the next time we are allowed to fire is. And just to prevent clutter and eventual mayhem in our game, we need to destroy the bullet after a certain amount of time has passed, so it doesn't remain in the scene for much longer than it needs to, than we care about it being there. So after 5 seconds, say I'm going to destroy the bullet. You could do this faster, you could do this slower. It's really up to how you want your game to feel. By 5 seconds, the bullets are very clearly going to be off screen, so I feel safe deleting them after that amount of time. Okay, and that should cover shooting. So if we go back into Unity here, you'll notice the player script has a bunch of other things that have popped up here in the script. We do need to assign these, otherwise the game will break. So let's go ahead and drag our spawn position into the spawn position slot, and the bullet prefab into the bullet prefab slot. Go ahead and save that, slap play, and bang, we can shoot. Look at that. We have made a shooter. Cool. Alright, so a shooter isn't really much without something to shoot at. So let's go ahead and make an enemy. The way I'm going to do this, I'm just going to duplicate the player. Slide this guy forward a little bit, maybe off to the side. See him. Alright, and I'm going to rename this guy to enemy, because that is exactly what he is to us. He is an enemy. And I'm going to remove the player script off of him, because we don't need him to be controlled by the player. So I'm going to remove the player script. But we also need some way to differentiate this guy from our player, because right now he looks very similar. So let's go ahead into our materials. And let's give him the gun material, and then give his sunglasses the bullet material. Now that is one evil looking dude. Right? Just screams malicious intent, so you feel fine shooting at him. Okay. Next thing we need to do, we need to have some ways to sort of register when we're shooting at things, when they collide, and sort of how to handle all of that. And for this, I'll be making a health script. I'm going to right click, create, C# script, and this is going to be health. So again, we see this familiar scene with a new script. So the health script is going to be pretty bare bones. It's not going to be a full good health class. It's just going to be a shitty implementation that works for our purposes and nothing more. But if you're interested in a better health script, I have some that I can pass on to you. Just DM me on the Discord, or ask me in person. Alright, so we create a public integer, max health. I'm going to set this equal to like 5 by default. The next thing we need is a private integer, which is our current health. We want this to be private so that other scripts can't access this and change it, but you'd have methods for that, ideally, to prevent access to information that other classes shouldn't have, and reduce data flow. Okay, we have a private int, and then in start, we're just going to set our current health to be our max health, so we're at full health. And then in update, we're just going to check if our current health is less than or equal to 0, then we're just going to die. You know, you could do some other cool things in here, like spawn particles and all that, but for our purposes, just destroy the game object, you know, we don't need to see it once he's dead. And then we need some way to actually decrement current health to get to the point where it'd be below 0. So, we're going to go ahead and use another function that Unity has, similar to start and update. This is the void on collision enter function. So this is a message that is sent whenever a collision happens between the object that this health script is sitting on, and another collider, with information about that collision contained in this collision object. So we're just going to check if collision.gameObject.compare tag bullet. So if the object that we collided with has the tag bullet, we haven't done this yet, but we will go back and do that in a moment. If that is true, then we decrement current health, and we can also go ahead and destroy, I can't spell today, destroy the bullet, because once it hits you, we don't need it to really remain around anymore, unless you want it to like go and ricochet off, but like that's not really something we're going to be concerned about today. Okay, and this by itself should work. The only thing we need to change is back in Unity. We need to go back to our prefabs folder, find our bullet, and then tag it with bullet. Now, this has remained over from my last sort of trial run through this presentation, but normally you'd have up till here and nothing else. You'd have to go in and add a tag, click on this little plus button to add a tag, save it, go back to your bullet object, and then make sure it is tagged with bullet. Okay, so now we go on to our enemy, add the health script, and maybe make this a lower value like 2. You'll notice that when we fire up the game and fire at the player, oh shit, I'm gonna zoom the camera out a little bit. 20, oh that's really far. 15, sure, okay. Yeah, if we go ahead and shoot at the player, or at the enemy, he disappears after he gets hit twice. Perfect. Cool. So now the next thing we need to do is also slap the health script onto our player. It's really unfair if you're unable to be killed. And just really quickly, let's try this out. Okay, that's working as intended. You cannot shoot yourself, or wait, can you? Really quickly, let's go ahead and check if we did shoot ourselves. We did, somehow. So, you know, just to avoid that ever happening in-game and, you know, cheating the player out of something, go ahead and add a little safety sort of skin width to our spawn position. We're just gonna increment it by some small value. So we're just gonna move the bullet forward from where it spawns a little bit, just so it doesn't have the chance of colliding with the player, you know, making the player feel bad that they shot themselves. Or you could leave it in if you want it to be like, you shot yourself, you're an idiot, you know? It's up to you. You can really do whatever you like. Okay, so this is pretty much where we ended up with last time, the actual tutorial on Wednesday. But I was requested to cover some more things, and so I will continue going into those today. Namely, enemy movement, shooting, and also, if I have time, the camera movement and tracking that way. So, let's go ahead and create an enemy script. Again, you'd want separate scripts for like shooting, movement, and all that, but I'm just going to throw everything in the enemy script. Another sign that this is really bad coding practice is that we're going to be copying a lot of code off from the player. So, we're going to be copying the shoot method. We're going to need that because the enemies will also be shooting. We're also going to be copying variables up here. We're going to be copying pretty much all of these, except the camera. We don't need that. So go up here, paste these in. We have all of that. Make sure we don't forget to assign our rigid body the start function. Cool. And I believe that's pretty much everything we need from the player script. So now we just need to do the logic for the enemies. So the first thing we're gonna do, we're gonna have them look at the so the way I'm going to get these guys to move is using the nav mesh, because I don't want to deal with sort of, it's like that has the advantage of having pathfinding built in, and I don't have to deal with sort of you know, making sure they don't clump up together and all of that. Instead, we can just tweak a few settings, and it'll work as intended. Now, the other thing that this does mean is that we won't have as much control, and also I didn't practice using the nav mesh before this, so it may or may not work. And in fact, that's seeming like an increasingly bad idea, so I think I'm probably just gonna do it in here and just have them be like shitty. Yeah, I'll do another video on nav mesh sometime, maybe in one of the streams I do on Saturdays. But okay, so for update, we want to find the player, look at them, and then shoot them. That's basically an enemy's goal in the game. So we're gonna create a public transform player. So this is just going to be a reference to the player's position at any given time. To do this, we could assign this in the inspector, but as a failsafe, failsafes are really nice. If the player is not assigned, i.e. it's null, then we want to go ahead and find the player. So we're going to go and use the find object of type player dot transform. So this will go look for any object in the scene that has this player script on it. Since our player is probably the only object in the scene that has the player script on it, this is fine to do. But ideally you'd also go into your enemy and add the enemy script and slide the player in there, and also go ahead and slide the spawn position in there and the bullet prefab to here. I'm also going to change the fire rate from 0.1 because that's pretty high to 0.8, and that should be good for us. Okay, so now we have to actually look at the player. Quickest way to do this is just to do transform dot look at player. Like if we go into our script, wait for it to come, or go into Unity after saving our script. Like this works. Since the player is never really changing vertically, this is fine. Like if the player changed vertically, you'd see the guy tilt back, look up at the player as he moved up or down. But since there isn't any vertical movement in this game, this is fine. This works. Okay, and then the next thing we need is for him to shoot at the player. Now, this is the reason why we updated the fire rate to be lower. You'll notice this is already looking to be pretty bullet hell-like. But you can change how this works if you'd like. The next thing we want sort of is to have some sort of way for the enemies to move. Now, you could get pretty complex with this sort of stuff, like have them strafe, have them look for cover, have them do all sorts of cool behavior. For us, we're just going to have them track down the player, and then try to avoid clumping up by maybe offsetting it, offsetting that position by a little bit. So, in fact, to control this, I'm going to create another public float, and this is going to be a public float pathing offset. I'm going to set this to like 2.4, something like that, I don't know. Yeah, that should be fine. Okay. I think, yeah, that should be fine. Okay. So the next thing we need to do is we need to get him to start moving towards the player. Let's see. Yeah, we have a move speed for them. In fact, I'm gonna actually make this a lower default move speed for enemies. We don't want them to be moving that quickly. That won't actually change in Unity. We will need to go change it, but just for any future instances of the enemy. The next thing we need to do, we need to start moving them towards the player. To do that, we'll get a vector3 direction to player, and this will be the position of the enemy minus the player position. In fact, actually, we don't need this, considering we're already looking at the player. So instead, what I'm going to do is I'm just going to move the move in the forward direction multiplied by our move speed. And I'm also actually going to normalize this vector. Safe. Multiplied by time.delta time. Oh, but you're right, that's why. So actually, since we want the enemies to offset a little bit from the player itself, so they don't end up all clumping together in a chase after the enemy or after the player, we're gonna create a vector3. Just move position where the enemy is going to be moving to, and we're just gonna take all of this and replace it with move position. So we're gonna have that. Cool, we have that, and then we need to offset it a little bit. So the way I'm going to do this, yeah, okay, I think the way I will do this is to use a random value between the negative pathing offset and the pathing offset, and then add that onto the position in the x and z directions. So float pathing adjustment equals random dot range from negative pathing offset to pathing offset, and then move position dot x plus equals pathing adjustment, and move position dot z. Oh, I don't know, something like that. This is probably like a really bad way of doing it. I'd never actually written this part of the tutorial out before, but I'm just kind of flying by the seat of my pants right now. So now, if we go onto our enemy, play, hopefully this doesn't look stupid, otherwise we'll have to do some... Ah, yeah, it does look stupid, because... Wait, hold on. Yeah, I did this wrong. This should all be... Then, by time delta time, I believe was the issue there. I believe that's the issue. Nope, he's just constantly stuck in 0. Can't be it, right? We'll see. If this doesn't work, I will probably... Okay, that's better. We just need to lower the move speed. Because he is a vicious enemy right now. As again, we forgot to change the moves here. In fact, I think I want to make that even lower, just because of how fast he is. But, okay, that might be too slow. Actually, that was okay. He just looked really jittery because of the random offset part. So I might try lower. Yeah, actually, I'm adding the offset. Okay. Yeah, I think what I actually want is for him to go to where the player last was and then chase the player around that way. That would be a better implementation of this. In fact, if I have time after this, like this works. So in fact, I'm gonna go ahead to our prefabs, make the enemy a prefab. Just drag a bunch of copies of him out onto the scene, so you can see sort of what this will look like. This is a tough game already. Thankfully, the enemies can shoot themselves, or shoot other enemies, I should say. And you can shoot other bullets. That stuff's kind of cool. I like that, so I leave it in, but it's up to you if you really want to leave that in or not. But yeah, that is working to an extent. If we have time after this, I want to see how long the recording's been going. But if not, let's really quickly make some camera script here. So we want the camera to follow the player. The quick and dirty way of doing it usually is to just parent the camera to the player so the camera moves with the player. The problem with that is when the player rotates, the camera rotates. Considering how much we rotate in this game, that's going to be nauseating. Let's go ahead and make a quick camera tracker script. It's going to be a camera tracker. So all this is going to do is take in a public transform target and a public vector3 offset. So in update, all we're going to do is set transform dot position is equal to vector3 dot lerp from our current position to the target position at a certain speed, which is also going to be public variable. And this is just going to be a float smoothing speed. And this by default we want it. So okay, I should really explain what I'm doing here. So vector3.lerp, all this does is linearly interpolate from vector A to vector B, meaning slowly go from position A to position B in a straight line linearly. And then the value here is between 0 and 1, basically the progress of the progression. So if we're at 0, we're at our current position. If we're at 1, we've reached our destination position. And anywhere between is just how far in between. So 0.5 is halfway in between the two. So we want this value to be between 0 and 1. And for that purpose, we're going to tag it with the range attribute between 0 and 1. Okay. And then we're just going to put that in there. Okay. And then we actually also want to add the offset here so we don't go into the player. So now we go to our main camera, add the camera tracker script. I have an error. Semicolon. Can't forget those. Okay. Actually, I should mention, the console is really useful because it pops up with errors. You'll also notice them down here in this very tiny bar at the bottom when there is an error. Yeah, okay. So we want the offset to be 15 units above the player. We also want the target to be the player. In fact, I'm going to move the player above all of these enemies and also the plane, just to keep the hierarchy a little bit cleaner. Anyways, back to our main camera. I'm also going to bump the smoothing speed up to like 0.5. So adjusting this will change how quickly the camera tracks after the player. And just to test this out, I'm going to disable the enemy so I don't die. Okay, there we go. That's working all right. Now let's lower that smoothing speed. I'm wondering if it's just the material that looks jerky, or if it's actually the camera. Looks like it's actually the camera. So if I make this 1, that's less jerky, but also there's no smoothing at all. But I mean, you can play with this and sort of see. In fact, I probably should have looked at my older camera tracking scripts that are much better than this. I might attach them in the description if I remember to do that when I upload this. But this is a pretty basic one that works to an extent. The smoothing speed actually does nothing. Basically what this is doing is just setting transformed opposition equal to this at the moment, since smoothing speed is 1. Like, there's no point for all of this fancy stuff, but like, I think it's been a really long video already, so I don't want to spend too much time on that. So, yeah, we're sort of just taking this as it goes. But if I forgot to do anything, or you know, if you want to see more in-depth stuff about things, let me know, comments or in Discord, whatever, and I will try and make a video getting to it. Most of this has just been kind of me sort of going ad-libbing it, but you can see that we do have a working top-down shooter. Extent, you can shoot bullets and stuff out of the air. You could change all of that with collision layers and stuff, but I feel like that would take too long to cover here, and it's already been quite a while, actually, now that I look at the... So I'm going to go ahead and stop the recording there. Thank you guys for watching. Hopefully this tutorial was helpful. Go ahead and catch one of my streams on Saturday at twitch.tv/fiscallydeficient. I'll be streaming most Saturdays to just some sort of game dev thing, either a tutorial, some sort of cool new feature overlook, something like that, and you might find it helpful. Alright,